So in this video, we're going to take a look at the ideas of trade and comparative advantage. And I'm going to start by just typing some answers. And again, I encourage you, if you have your own copy of this Google Doc, that you make your own answers, you type them in. But in addition, I'm going to solve some of these problems by writing on the table. So it might be helpful to have like a blank sheet of paper next to you so that you can rewrite some of these and solve them as well. So let's start off with the idea of absolute advantage and comparative advantage. Absolute advantage is the idea of having the ability to produce more of a good than another, and we could say another country or another person with the same resources. So this is the idea of like the same amount of time, the same number of workers, the same amount of factory space, that kind of thing. You're just better at it. You're faster at it, right? So somebody might be faster at cutting the grass than you are because you got to take breaks all the time because of your allergies, right? Comparative advantage is the idea of having lower opportunity cost of producing a good than another person with same resources. And that's the idea that effectively you are better at, if you have the comparative advantage, you're better off doing that because you are more specialized at it, right? And so what's the benefit of specializing in trading according to comparative advantage? It's the idea that if the two people specialize and trade, and basically they specialize in what they're good at, then they both can consume more than if they did it alone. And that's pretty exciting stuff. That's what the biggest benefit of trade is that it allows us to specialize in what we're really good at, and then we buy the things that we aren't necessarily as relatively good at. And what is a way to determine whether terms of trade are acceptable? Terms of trade, oh, that's in bold. I don't know why. Let me unbold that. Are okay if the term is between the two people's opportunity costs. And we're going to see what that means here in just a second, but that's actually what the definition of when it's acceptable. If the term of trade is between the two people's opportunity costs. So let's take a look at this table below. And I'm going to switch to my pen here, and hopefully it's not too messy. So this table shows the output of China and the US of cars and toys, and it says who has comparative advantage, who has absolute, and then there's terms of trade. So the first thing we're going to do is actually figure out which one has what their opportunity costs are. And so we're going to write one car because we're in the cars column. And then we're going to say the outside number, 100, over the inside number, 100 over 25 is 4 toys. So what that means is that for China, because we're in China's row, right, that China can make one car or they can make 4 toys with the same amount of time, right? So every car they make, they have to give up 4 toys, and vice versa. Every 4 toys they make, they give up 1 car. Now let's look at the United States. For them, 75 over 50. So that means for them, it's 1.5 toys for every car that they make. So they have a lower opportunity cost, right? And so for them, they have the comparative advantage in cars. Now let's look at toys. Let's solve them. One toy, because we're in the toys column, is equal to 25, the outside number, over 100. So that's 1/4 of a car. So for the Chinese, when they make a toy, they only give up 1/4 of a car. For the United States, it's 50 over 75. So that's 1/3 of a car, right? 1/3 of a car. And so for them, we would say, or that's 2/3. A little brain fart there. 2/3, that's more than 1/4. So we would say the Chinese have the comparative advantage in making toys. So China, and we can actually say because 1/4 is smaller than 2/3. And so what we're doing is we're comparing this value and this value. Now, who has absolute advantage in cars? Well, who could just make more cars is 50 is bigger than 25. That's the United States. But it's not because they have comparative advantage in it. It's not because they have comparative advantage. It just is because they can make more with the same amount of resources. Now the next question says, if terms of trade are one car for 5 toys, will trade be good for China, US, both, or neither? Now, one thing about these kinds of questions is they're never neither. They're always good for at least one and sometimes both of the parties. So let's check. One car for 5 toys. So we're already given one car. So let's look at the cars box, right? It says one car. And I'm going to rewrite this right over here where it says one car. And then we're going to have a little number line. We're going to have a little number line. And on the top of the number line is 4 toys, and that belongs to China. And the US is 1.5 toys. Now, if we were given one car, we're given one car for 5 toys. That comes from the term of trade below. If we were given one car for anything between these two values, in here, they're good. They're good for both. So that's what I mean when I say term is between the two opportunity costs. But because it's above China's, right, the 5T is up here, it breaks through China, so it's bad for China. So it's okay for the US, bad for China. Now, the reason why is 5 is bigger than 4. But it's okay for the US because 5 is bigger than 1.5. And so we'd say 5 is bigger than 1.5. And I know that sounds a little bit like, well, how does that explain anything? Well, here's why. The United States is making the cars. So for them, if they can get 5 toys, that's great. It's below their minimum price. So anything below 1.5 would be bad for the United States. But anything above it, they're good because they're the ones selling this item. So they want to get as many toys as possible. Now, for China, this is their maximum price they're willing to pay. So for them, 5 is bigger than 4. That goes above their maximum price, so that's why it's bad for them. Now let's do a different style of problem. The next style of problem says, use the table below, hours per, right? That's a really important distinction here that we're going to make. And in this distinction, it's the idea of now we have an input problem. This style of problem tells us how much time or how many workers it takes to make a particular product. So how much time it takes to make one car or one toy. So in this one, we are going to rephrase how we solve the opportunity cost. So we're still going to say one car, but now we're going to say the inside number, 25 over 100, because it's an input problem. So one car is 1/4 of a toy for China. And one toy for China now is 100 over 25 is 4 cars. So in this case, right, we're kind of flipping them around a little bit. And now we're going to do inside number 50 over 75. And so we find that this one that's 2/3 of a toy. And then over this one, 75 over 50. And again, inside over when it's an input problem. And we know it's input because it tells us the hours. So this is going to be 1.5 cars. Now we look at who has the lower opportunity cost. Well, in this case, the Chinese have it for cars, and the United States has it for toys. So we'd say China, and because 1/4 is smaller than 2/3. And then who has absolute advantage in toys? That's just asking who can make it faster. So in this case, it's the USA, and that's because it only takes them 75 hours, and that's less than the Chinese's time, which is 100. Now, again, it's just a coincidence that the absolute advantage corresponded with the comparative advantage. They're different things, right? And in fact, we don't really care how much time it takes them. If you have comparative advantage in it, that's what you should do. Absolute advantage doesn't really tell us very much. Now, the last part here says, if terms of trade are 2 cars for 1 toy, is it good for China, the US, both, or neither? And again, neither never works, so ignore that. 2 cars for 1 toy, so we're in the toys column, we're right here, and we're going to say that 2 appears between 1.5 and 4. So good for both. And that's because we could say 1.5 is less than 2, and 2 is less than 4. And that's an acceptable answer. Now, the last part, if the Chinese triple their productivity of cars only, now who has comparative advantage in cars? So in this one, we're going to kind of really quick redraw basically this thing up here. And I'm going to show you what ends up happening with it. So we've got CHUS and 1 car, 1 toy. Now the toys side is going to stay the same, 175, and the American cars are going to stay the same. But now it's way less for the cars, for the Chinese. And I probably should have made this a little bit easier to do. So we're just going to round it and say 8, right? 8, even though it's a little bit higher than 8. It takes a little bit longer than 8 to do that. And what we can do is 2 ways of solving this. One is we can use what's called the quick and dirty method, which is cross multiplying basically 8 times 75 and 50 times 100. And because it's an input problem, we choose the smaller value. And whichever one is smaller is tells us the comparative advantages, or we can solve it just like before. So for our purposes, right, we can do 1 car is equal to, and then the inside number over, and so that's 8 over 100. Boy, that's a terrible, terrible problem. I should have made it a lot easier. That's 1/25th. And then 1 car for these, the inside number is still 50 over 75, so that's still 2/3. So obviously the Chinese now have it in cars, but they still do, right? They still do, and that's because 1/25th is smaller than 2/3. So at this point, you can kind of see, you can kind of see how to solve those is basically change the number that you're given. So it's possible you'll see this type of a question when they give you an output problem like what we had up here, and it's possible that they give you this type of a question with an input problem. Hopefully this helps you with trade. I'll see you next time.